Сейчас долгожданный.
And now the long-awaited Dmitry Ivanov and Maxim Milyutin will tell us something about embedded partitioning in Postgres and external solutions. Hello all. There are so many of you here. I did not even expect to see all of you. So let me first introduce ourselves. My name is Dmitry Ivanov, and in case you don't know who I am in charge of partitioning in Postgres Pro, and we have done extension PGPassman that is needed to improve partitioning, speed up queries at vanilla version of Postgres and at Postgres Pro as well, where it is used as an embedded engine of partitioning, and it has its own wrapper as a declarative syntax. And together with me, Maxim Milyutin will give this presentation. He used to work with us, but then he decided to face real life and the extensions that we develop and test on our laptops. Max decided to look at the reverse side of it and to be responsible for the input of such people as me, that sometimes in reality turn out to be somewhat different. So our presentation today will be structured in the following way. I will start with some brief history and background, including some information from my previous presentations, and then I will give the floor to Max, who will tell us about his studies and researches. And regrettably, we did not manage to include some information, but still, we would cover the major part of it, and then we will have a Q&A session, and including the part on ScaleDB. So let us start. Let us have a look at the participants of our contest. I have given presentations on inheritance, on Postgres 10, on Passman, and what we're going to hear today is inheritance, Postgres 10, 11, PGPassman, and what we're going to consider today. Partitioning is a complex thing, and I believe that you are aware of it. And who has used partitioning? Raise your hands. There are many of you, great. So you understand that very often you can encounter some issues while partitioning. So we will consider ways of partitioning, work with a large number of partitioning, 1,000, 2,000, up to 10,000 partitions, and we have considered even more extreme configurations, but that is not that interesting because everybody starts behaving badly there. API for partitions management will be touched upon briefly. Accessible query optimization is another point, and here we would like to tell you what will be there in the 11th version for sure, and most likely, and how to solve the problems. And I believe that is something that we will discuss during Q&A session. So, introduction. What is partitioning? When we face a situation when it is not really handy to get data in the same table because indexes bloat and select is running down the disk, we need to introduce some condition that we can see only in some parts of a table on certain criterion, and the tables can be broken down by date. Partitions are created on months. All partitions are not interesting for us. How was it done before? I'll just remind you, and those who have never heard about it will hear it from you. There is my table, and that is something that we are going to address sending queries, and on the inheritance mechanism from it my table 1, 2, and 3 are inherited, and if we have select my table done, we will have automatically drag of data from these tables, and it will be done with the help of APN node of executor in planner, and there are its modifications like Perl, APN. So the most important thing that you have to remember is APN. And apart from these inheritance links, there are also check constraints relations that condition the data that have to be stored there. And this has two ideas in mind. First of all, we would not like somebody to manually input data into partitions that do not belong there. Otherwise, we would not be able to guarantee that the user will see this data. And secondly, it is nicely, and thirdly, it can be used to optimize queries with correct approach. The second element of our partitioning is that we need to insert data, and we should insert them not into the main table. We should make it bodiless, so to say, ideally. It makes that we make it vacant, we do not insert data there, but we add a trigger with the help of which we distribute data. And nobody makes you do it that way. As a table, there can be viewer, and as a trigger, there can be rewrite rules. But as you understand, that is not really interesting to us. That is like a historic tab. And trigger will distribute rows at insert. Now let us have a look at how timescale db is arranged, and I am giving the floor to Max. Thank you. Timescale db builds partitions on check constraints as well that are defined, and it splits on two intervals, one by default by date, and the second key is optional, that is by the hash of another field. And therefore, we have two checks on the HD partition, and when we condition one of the fields, the needed partition is selected. And with this approach, we can optimize the query on two conditions independently, because if we did partition in depth, we would have selected on the first criteria first and then by the second. And in this case, there are two-dimensional grids of the chunks, and hash can choose a map both by optional hash and temporal intervals, because as you might guess from the name, timescale essence is to write temporal rows and then process them. So we need to analyze temporal rows, and but then there might be a need to extract data on another criteria. And I did not write arrows on the slide here because inheritance mechanism is not used here. Two indexes are used instead. One index on the additional key, and optimization is done in this way, and there is the own catalog that has links between hyperchunks, and it is like a thing in its own. So it is an extension of Postgres, and it is like a time series database. It is positioned like that, and it is included in that part in DB Engine's ranking. And we have to mention PG10 here. It is different from ordinary inheritance, not that much. First of all, it conceals constraints under the rug, so they are not visible, and my table is a full-scale view, and there is nothing that can be inserted into it. However, in PG11, I understood that you cannot always address all the issues by this way, because there are some data that cannot be always inserted into the default main table, and then there we have default part, and there can be inserted data other data. And we need to tell something about Pathman. Pathman is not different from inheritance. It uses check constraints to build temporary views that are stored separately to optimize queries. The format is the same as with ordinary inheritance, but we get additional advantages. Pathman supports hash and range sectioning, optimization of planning and execution, and we also have inserts not through triggers, and we have automatic creation of sections during inserts and non-blocking sectioning.
And finally, it supports RDW. So, a few words about Pathman. This cache view is distributed into two layers, two levels. We have several cache layers. First, the array, where the data lies sorted by more or less attribute. So you go left, go right. You select what is more, what is less, and you find a certain value, and the key matches, and you select all the partitions. So we will use some analog of binary search. In case of hash partitioning, we've identified the partition right away. Additional cache helps us to, in case a partition is amended, is changed, we can discard the main array. We get the left and the right border, and when we invalidate the cache, if new partitions are added, we just rebuild the array, and all the boundaries will be already there. Right. What is the disadvantage of Pathman? And not all prepared statements are equally useful. What does this mean? Well, the thing is that practically all the partitioning works with the prepared statement not so well, because we can easily optimize, or relatively easily can optimize, if we have known values. If we have the partitioning key, if the partitioning key is less than a certain constant, then we can select the right partition right away. If it's not a constant, if it's a parameter, then you start getting problems. For instance, you need to calculate the entire parameters for all the partitions, and then when this value is known, you only select the partitions which you need. But it will take still time to plan access to all the other sections. To solve this issue, we had to create our own execution node, which would do this bit of work and would optimize this a little bit better than the full shuffling. But still, it's not an ideal solution. Without connection, things look bad, because there's this well-known joke about Postgres. I get connected to the database, I did a query, it was executed in some time, but next time I did the query, it was much quicker to be executed. Please, dear developers, you should correct this error. So after the first access to a table, it initializes at a lazy stage. Pathman does it even worse. So if we keep breaking the session altogether, we will not see any profit at all, because it will rebuild the cache every single time. So you need to do a pool of connections that will keep the progress and will keep the connection. Max can tell a few words about it. Right. The way out of this predicament of the first long query is as follows. You need to warm the local cache. When you initialize the connection via the pool, so this connection has to live long. Furthermore, the present pool connectors make callbacks or offer you options for queries where you can do a query before this connector is given away to the client. One more thing. Another disadvantage is that the triggers aren't inherited. Primary keys don't work, insert and conflict does not work. The second two problems, these two conflicts are because the global index problem is not solved. I'm sure you have heard about it, but I would like to emphasize it. Without the global indexes, you cannot force referential integrity. You cannot make sure that this data is already recorded and you don't have to delete it, because there's no way to look through the entire table effectively to see that the data is there. Okay, I would like to add. Basically, the global uniqueness can only be ensured via global links, but also via local partition. If the partition key matches the partition key, then this is the key. Furthermore, we're now developing which will help us to deal with local indexes. The values are checked in all the local indexes in all the partitions. Good. One about the first query problem. It's a short illustration. If there's a table which is called partition, if we join it with another table, then the first query will take 15 milliseconds. It's not so much what type of hardware you're using. Just to illustrate that, first the planning time will be 15.5 milliseconds, then it will be 45, just because the first time it will take some time to do cache. You need to remember this. Now about the timescale DB, Max learned more about me, about you than I do. Okay, thank you. Timescale DB, like I said, it's a database in itself. When you initialize this extension, it creates an internal catalog of partition tables, or you can also call them hypertables. This table describes how the table is partitioned, in what chunks it is broken, what are the dimensions in the partitions, etc. It even indexes the intervals of the chunks. Like we said, it is broken down into sections by the time parameter, and it is by default. Furthermore, in an ideal case, you don't even have to set the interval of this partitioning, because the system should select it automatically, so that the last partition is always the last partition, and its index is always stored in the memory. So the request for insert, for a read of the latest data should be answered as quickly as possible. That's right. It's important to understand that there's a certain buffer in the present-day databases that stores the pages and indexes. Timescale DBA ensures that the latest tables, the latest chunks, the latest indexes are always in the buffer cache, so that you don't bump into the disk when you need to access it. This is why the routing partition mechanisms are focused to look through the indexes, to do the query, and it won't take much time because you don't look through the entire disk. This is how it works. Okay, one more thing. It automatically selects the intervals, the time interval, but it's still at the proposal stage. At the moment, all they do a recommendation about the size of the last interval. So basically, there are certain settings which they recommend that would help you to get this condition, but in the future they intend to make it by default. And finally, last but not least, additional functions for analytics. Clearly, if it's time series DBs, you need to process the data somehow, and need to be it will be much more efficient if they give you an opportunity to do it by themselves. With respect to Postgres, summary, it has declarative syntaxes, it's arranged in lists sectioning. The hash section is not stored on the disk. And the most important feature, which should show up in version 11, the hash sectioning will be there it will not be simply smart, much smarter than Pathman. We had to section into a constant number of partitions in Pathman. Once you have sectioned, you will not be able to use anything else, which is more easy to use. But hash sectioning in Postgres is expected to be more easy to use. You'll be able to drop partitions and to break them down into smaller bits to do total rehashing of what is already there. The default partitions, which I have just mentioned, for data which is difficult to use. And the most important thing, lots of interesting optimizations which will help to unparallel data in case you do your own sharding, customized sharding. Thing is that you will not always have same conditions, but you can have FDW so that each partition is on a remote server. If you could do queries in a parallel way, if you get the results in bits and then aggregate, then that would give you a lot of profit, and I will tell you about it shortly. But before that, a few words about the existing approach, which is not so good. You can make a table with two columns, ID and value. We'll partition by range just because it's a very good example. We'll partition by two columns at the same time, just to show you that you can insert several columns into the key. We add partition test1, test2, syntax. I didn't like, because it's too wordy. But still, it's about my personal taste. Many people like it. So we create a partition. The tables can be established immediately as a parent table, or they can you can create a ready partition with data. It is very important. If you do gradual migration, you will be able to add a new solution to this partition table. Clearly, SQL has a certain blows and whistles. So what's the disadvantage? They're quite clear. So far, there's no way to merge or to split or to work partitions. So to be able to do merge, to merge several partitions, which are one beside the other, you'll have to detach these partitions first, the 2 and 3 which you would like to merge first. Then you take data, drop it from one to, copy it from one to another, and then you drop the third partition, and then you reattach it with the new boundaries. Clearly, the disadvantage of this approach is that if you do this in one transaction, it will take too much time. You'll have to parse these statements. And there's another important problem, and it is the parent table has access of duty block. So when you do this, you cannot even access it for reading. You want to do anything with the partition, attach, detach, drop, whatever you want to do with this partition schema, you will have access to exclusive lock. And those of you who has seen it in the monitoring statement know that it is the death of your database. The table will stand still and everybody will stand on the queue waiting for this to work. So how do they propose to solve this problem? Based on my discussions, personal discussions, I came to a conclusion that they have no plans at all. PG apart could make it better and smarter. We block it manually using log table. You can read it, but you cannot. Then you could create a partition in a different place, and then you attach it very quickly so that you won't see basically how the log happened. And standard problems which follow from the fact that there are no global indexes. Oh, actually, that reminds me. You cannot create partitions automatically. It is not available. It is not proposed to be included in the future. It has not been possible to create an index until version 11. There are local partition indexes in the version 11 where you can create indexes for the parent, and similar parent indexes will be created for children. it is impossible to use unforked other than do nothing, because there are no global indexes. And last but not least, cross-partition update is not available until version 11, because if you change the partitioning key so that the line has to move, so this is not possible. We hope that it will be there in version 11. Now the most important thing is what is new in version 11? With flexible hash sectioning, default partition, local partition indexes, and finally query optimization. Some of them are already in the master. The rest we hope will also be in the master. The parallel append, for instance. I'm sure many of you have already been able to estimate the parallel sequential scan. I will describe the advantages very clearly. If we have a very big table, then the larger the number of workers, the more they can work independently. They can extract, they can store, they can send the data to the main backend. This can win you some time, just because we will be able to utilize the CPU and the disk just a little bit better. How many workers can be used depends a lot on the size of the table. So if we're going to use a usual sectioning in order to reduce the number of sections, then we will not get much profit, much advantage. You will not be able to use many workers in a small section, and basically it does not make any sense either. It is much better, much more efficient to take each section and to scan it separately, because parallel scan scans the same table. And it says that this process should scan odd pages, this process scans even pages, etc. So they scan the same independent pages using the same table. If we could scan each partition independently, that would be much more efficient. And now this is available in the master. Partition-wise, Max will tell you better about it. Now let us look at how hash partitioning is done. We're showing you an example of how you can scale one hash partition without touching other partitions. Let's say we break this table in by the integer fields, and we can see that for each partition we specify two values. The module, the hash value of the key, and the remainder. This is something against which you compare the first bit. So clearly we have broken this down into two partitions. The first has 0, the second one has 1, and we want to scale the first partition. We detach it, and then we set a different module for it. Basically, you can calculate it using the following formula. You take the number of partition by which we scale it up, multiplied by the previous value of the module. And at the end, you set the values so that the tuples from the previous partitions would be distributed into new partitions, and we attach them. So all you need to do after that is to distribute the data in this in 1, 2, 3, in foo 1, foo 2, foo 3, or multi-level partitioning. It's another interesting case. There's this wide-known opinion that hash partitioning distributes data in an even way. This is not always so. If your partitioning key is distributed unevenly, if there are majority elements, then these elements will increase the partitions to which they are going to go. We have seen an example on the internet in a case of sharding, which says it does not make any sense to do sharding for social network users by user ID. Not just the name, but also the user data. As soon as we get a popular user, Justin Bieber, for instance, who has got lots of followers, then they will all go to one shard. And this shard will be carrying all the load. It will contain all the data. Whereas in Postgres, when you use a multi-level inheritance, you will be able to take this big partition and to break it down into sheet default partition. You list all the majority users on the sheet, on the list, and then you do the rest with the second partition. As a result, each partition in its final state would be more or less the same size. And finally, we need to tell you what happens if the number of partitions is too high. If you do partition using the inheritance or the current 10, then we will be limited by one very important feature. The thing is that shuffling, the selection of partitions that match the conditions happens only after full shuffling. So we have to decide for each partition whether you need to take data from that particular table or you don't. What is the disadvantage of this solution? If we have done 1, 2, 10 partitions, then we won't see any major difference, because the scale is different. But as soon as you see, make 200, 300, 500 partitions, then you will see the following problem right away.
For example, we have planned a very simple query. For example, we see that we have append, and it is an example on the basis of inheritance, but it is also actual for 10. So we have a parent table 4, and it has one section for 1, where it also has read, and for 1 obviously met the conditions. And interestingly, we can see that query execution time is really nothing, but the planning time is a really huge issue. So we created 10,000 partitions, and to plan an effective query, it took us a really massive amount of time, because for every partition we decide independently where we're going to include it or not. So that is a totally inefficient approach, and now everyone is trying to somehow fix it. And now let us show why did it so happen. I showed a ship here on purpose, so we can see these layers, and the lowest layer is the time of query execution, so along the x-axis. And we see the stack of functions of how and where we entered, and we can see one specific function highlighted green is going through conditions for every partition. So we determine whether we exclude the table or not. So 50% of time goes just to decide which partitions we need and which we don't, and that is something that doesn't make sense, and that is why we started dealing with Pathman. And benchmarks will tell us something about the results, and we are now going to tell you something about other optimizations as well. So in version 11, partition-wise aggregates are being developed. That is sending aggregates to append a node to partitions themselves. What does it mean? It means that instead of taking away all rows from the table and then apply aggregates to them and some value like count, we can take it separately for every partition, and it is most topical if they're somewhere far away in the table. So we send the request there and then receive certain response. And as for what the plan looks like in this case, here you can see a plan with frame tables. And when we unparallel the aggregates computation along certain streams, then we win something here. And in other cases, there will not be any difference. Here, the aggregate is sent to a foreign scan, but regrettably it is not sent inside. So first, the data are scanned at some remote server, and the main server receives this data, then it computes aggregates partially and sums them up. So receiving from each partition the quantity and the value, we would be able to have an overall result at the node itself. And now we would like to tell you something about parallel append and how to see whether it worked or not. So parallel append here, I need to say that parallel queries are mainly used for queries for heavy data. And query is paralleled in processes. And when we, in this case, we send the conditions on which we compress the selection received to our partitions, therefore reducing the amount of data that goes along the process. How to read this plan? So here we can see that there are two workers, and there is the main leading worker that is active in parallel with them. And the best way of seeing how many processes were scanned is to have a look at the number of loops, or at the number of workers executed. So the counter that says how many processes scan the table is shown by the number of loops. Partition-wise join is one of the most interesting things. There is I don't remember what it is called in work, but when we have one table that is partitioned and another table that is partitioned in the same way along the same key, then we can compare all partitions from one table with all partitions of another table. So it does make sense to compare each of the rows from the first to the second, and it makes sense to immediately do partition-wise join to determine which partition meets which, to compute it all optimally. So if we have foo and bar tables and they have two sections, and foo 1 corresponds to bar 1 and foo 2 to bar 2, instead of having two joined to append that gathers foo 1 and foo 2, it makes sense to do immediately foo 1 and bar 1 and foo 2 and bar 2. And now they try to execute it, and we hope that it would get into PG11. Another optimization, most topical for queries on temporal data, that is when we need to receive top values sorted in reverse order, that is the so-called sorted append. What happens in this case is that append node under itself orders partitions in such a way that the partitions that mean the last temporal values are at the top, and only they are scanned and the rest are not. The benefit is obvious, and we're getting at the last results. Here we have a chance to compare how fast the query receives a response. So that is the time of one query execution. So we tried to assess the planning time, and it is well seen here. So we compare ordinary inheritance, PG11, PG10, and some options of Pathman. And we can see that PG11 goes neck to neck with Pathman, both warmed up and non-warmed up, and all the other are somewhere high. We increase the number of petitions and see that the response time increases heavily as well. This chart is not really successful. Here we measured TPS. It minimally filled petitioned tables and looked at the dependency of TPS on the number of petitions. And we see here that the Pathman leads really strongly, and we also considered one case that we applied in Wildberries when we encountered an issue of larger petitions, and we implemented the partition pooling in an applied way. As a PG scale procedure, and we had binary search, and we divided the whole range by half, found the needed petition, and read it. Here the throughput is not lagging behind on Pathman side. So the question is whether we need to do that or not, because it is obvious that if we write our own application that executes proning in the same mechanism, we can receive results that will be not worse. The question is whether we want to do that or whether we want to have it as a base. And here is a bonus part, and that is benchmarks that I showed when I compared Pathman with PG10. And as we saw that PG11 and Pathman go neck and neck, we can show and we can use a comparison of Pathman with PG10 as a standard, as a benchmark, and Pathman is shown as a prototype that Postgres will attain. Postgres will be as performance. So let us have a look at the benchmark. We have 72 physical cores, 500 petitions, 3 million rows, 1 kilobyte each, and we have partitioning by row, and there are 6 different workloads that are considered different, all different loads, and that is the reference to the benchmark, the link to the benchmark. And here are some settings: work mem 512 megabytes, shared buffers 32 gigabytes, synchronous commits, and to avoid hanging up, don't mention that. Don't notice that. I took it from another presentation. So the first thing that we tried to do was to have a look at the time needed for data inserts. I am trying to wrap it up as fast as I can. We have several slides left. So first we tried to insert data, and Pathman did it quickly, and Postgres did it in 20 minutes. The reason is something that we didn't manage to find out, and this dot timeout was to show that insert queries are not cut out. And Pathman inserted it in 20 seconds and Postgres in 20 minutes. And in 50% reads and 50% writes, and 95% reads and 5% writes, and 100% reads and insert and select of the most popular values and small range of values. So very different loads, including read, modify, and write, a random row. We see the same situation when Pathman outpaces Postgres by a large factor. And I believe that is the end of our useful part of the presentation. If we have time for Q&A, let us hurry up. Yes, you have 5 minutes left for Q&A. Hello, my name is Maxim, and the question I have is as follows. So you said, when I break my table down into several partitions, the table will be an abstract thing under which I will have those partitions. So the question is, how shall I prepare the clients, or will nothing change for them? Clients, you mean your apps? So for application, nothing should change because you will have inserts and updates, and they will transparently spread around the data. So the goal of partitioning is for to notice anything, and the base will take it all upon itself. Thank you very much. And as when we go to partition tables, what traps can we expect? Well, different traps, I believe, and Max can tell something about them. The main issue and the major issue there will be uniqueness on non-partitioned key, and it proceeds with all the problems with foreign key, primary key. Ideally, partitioned table should leave the abstract view as if you work with an ordinary table, but there are always some nuances. And another part of issues, as there will be many partitions and they will be independent tables, the most important thing is how you will set a vacuum and how it will run, because if some change goes along all the base. Naturally, there are some limitations on some tables in terms of vacuum and their start. So the most important thing is what order they will start in and which table they will start processing first. And there might be issues with maintenance when we glue partitions together and try to cut out some old ones. And once in Telegram we had a discussion on what is better, to come up with a small, new, fresh partition with new data, or deal with one old with unnecessary data that we take once in 5 days. And I said that, yes, you can come up with many small partitions, but you can do that if you are sure that merge of old partitions will not lock the context of the rest of the table, because if we do something with the partitions, then the main table will be locked. So if we come up with many partitions, we have to be maximally sure that when we write, read, and have other transactions with other partitions, we will not be encountered by blocking access to everything. I believe that is really critical to remember, and I hope that I have answered your question. And the last question. Sorry, I would like to say that right after the presentation I will be ready to answer all your questions to any extent. Hello, my name is Dmitry. So I would like to store the data that I work with in one partition, and as for other partitions, to store there some old data that I use very rarely. As for transferring old data for slow storage, for example, I would like to store an SSD, what I work with all the time, and I would like to also store something in Postgres. So what is the practice? And it would be great if we make them read-only and store them on slow disks. The question is somewhat tricky. So I have already said that Pathman was done as an extension, and it was developed as a proof of concept on the one hand to show the opportunities on optimization, but then when we received the people who started using it, and it is being used, they started demanding such things as sections joining and shifting, and in case of PG10, you will not be able to do anything. And I have already mentioned that. In case of Pathman, it is possible, because if we do not have selects for the table, if we just do not get into the sections that you archive or move, you will not notice anything. You will encounter issues only when you start up a session, warm up a session. And if connections are created and killed all the time in the field, and if in a connection you try to make a query to a table, even though you did not need these sections, still there will be access to them, and for constraint, and you will lock yourself. So the question is either you need conveniency or speed of query execution. It is hard to word a best practice, but anyway, it will not take much time, and in case of Pathman, you would be able to transfer it all and will not notice it. And instead of Postgres, either everything is easy and you use inheritance, or you are caught into it. That is the way I see it, but I might be mistaken. You understand it perfectly well. Thank you very much. Let us thank the speakers.